Hi, everyone, and welcome to part 3, the final part of my Unit 1 video series on essential chemistry skills you'll need throughout this year. 3 parts, but these will probably be more substantial than some of the other parts we've talked about before. Density problems, and conversion factors. Let's jump right into it. Density. Probably have some familiarity with this. The main thing we want to understand is what density is as a concept, what its mathematical formula is, some of the units you might see, and ways to rearrange a formula. So what is density? Well, it's a ratio. It's a mass to volume ratio. It's how densely compact, okay, I shouldn't use the word in it. It's how tightly compact the matter of something is. Now, in terms of its formula, we calculate density as mass over volume. So something with a lot of mass packed into a small volume is going to have a high density. Something with little mass in a larger volume is going to have low density. We can simplify this as D equals M over V as our formula, which we should memorize. One way to remember this is the density fox. Do you see the density fox? How about now? You see the density fox there? Some whiskers and ears there. So I think, okay, maybe not with the eyes there. But yeah, that's one little way to remember this density fox. Or just memorize it, D equals M over V. Okay. You should be able to rearrange this formula to isolate any of those 3 variables. This is basic algebra here. For example, if I say, we want to solve for mass. What is mass? Well, mass has volume underneath it, okay? It's currently being divided by volume. So to get that volume out of there, we multiply both sides by volume. Volume reappears up here next to the density. So density times volume gives you mass. If we want to solve for volume, okay, let me clear this out real quick. We want to solve for volume. We need to get the mass out of here. Now, common mistake I see is people will go like this. They'll say, all right, mass is on top, so I'm going to divide both sides by mass, and mass will leave. So it'll end up being density over mass equals volume. That's not correct, because once mass leaves, you're not left with V. You're left with 1 over V. So that's not working. You could flip both of those and be correct. But the better way to do this, to isolate a denominator unit, do it in 2 steps. First thing, just get rid of the denominators. I always say I hate denominators. I want them to go away. How can I get rid of this denominator? I'm going to multiply both sides by V just to get the denominator to go away. So times V on the right, times V on the left, and I'm getting D times V equals M, which is exactly what we said for the mass formula. And now that we have no denominator, I'll bet you can tell me exactly how to get V by itself. Divide both sides by D, and you end up getting V equals M over D. So you should be familiar with how to rearrange the density formula to get you any of those 3. If you want something to help speed this up, there's a triangle you can memorize where we have D, M, V in a triangle like this. Now, if you want to memorize this, it's useful because you cover up whichever one you want to solve for. Okay, cover up the D. Now I can't demonstrate it with the 10. So cover up the D and you are left with M over V. Cover up the V, you're left with M over D. Cover up the M, you're left with D times V. So it's useful for seeing the formula that way. But you got to have the formula correct in the triangle, okay? You definitely need mass at the top. Technically, your V and D could be switched, but you need mass at the top. So one way I remember this, okay? We're at the age where we're starting to get licenses, permits, that sort of thing. So you've been to the DMV. You know that it's a mountain of paperwork you got to fill out. So what I say is you approach the DMV mountain. You have to scale the mountain of paperwork to get your license. DMV mountain, like that. So if you want to memorize this, that works. If you want to just memorize the original formula, as long as you can rearrange it algebraically, you're in good shape. Last thing I want to talk about is how density relates to water. Water has a density of 1 gram per milliliter, or 1 gram per centimeter cubed, because as we learned in the volume lab, milliliters and centimeters cubed are the same thing. So again, water has a density of 1, and generally that's given 3 sig figs, 1.00 grams per milliliter. Technically, this is temperature dependent, and we generally use room temperature, about 25 degrees Celsius for that. We can generalize though and say water just has a density of 1. Technically, if the water is a little bit warmer, the particles spread out a bit because they're moving faster, and the density dips a little bit below 1. That's why warm water floats on cold water. If the water is a little colder, the speed slows down a little bit and they kind of come together. I know you're thinking, hold on, doesn't ice expand? Yes, but cold water contracts before ice expands. It's tricky. So yeah, actually cold water at like 2 degrees Celsius is the most dense, like 1.01, something like that. Anyway, let's simplify and just say water is 1 in grams per milliliter or grams per centimeter cubed. That being said, anything with a density greater than 1 is going to sink. Anything with a density less than 1 is going to float. So that's kind of the overall gist of density. Let's go through some density problems. So calculate the density of a 571 gram piece of metal, that's your mass, that occupies 92.0 milliliters of volume. All right, should be pretty simple. This is like a plug and chug type question. You plug the numbers in, you run it through your calculator, you get your answer. D equals M over V, which equals 571 grams divided by 92.0 milliliters. You always want to include the units in your setup, okay? That way you can make sure the units end up correct. Is anything going to cancel here? No. The proper units for density are some mass unit divided by some volume unit. Could be all sorts of things. Grams per milliliter, probably the most common one you'll see. 571 divided by 92.0. Calculator tells me 6.2065 and so on. Lots and lots and lots of numbers. But we now know exactly how we're going to report this. We're dividing 3 sig figs, 3 sig figs, 3 sig figs in my answer. 6.21. And my unit is grams per milliliter. Right there. What is the mass of zinc? Density equals 7.13 gram per milliliter. That will fill a 36 cubic centimeter space. So we're solving for mass. dmv mountain. Mass equals, you cover up the m, d times v. Which equals my density, 7.13 grams per milliliter, times v, 36 centimeters cubed. But we have a bit of a problem here. My volume units aren't going to cancel like this, or will they? Fortunately, since milliliters and centimeters cubed are the same thing, we can just rewrite this as 36 milliliters, or rewrite that as grams per centimeter cubed. Otherwise, we would have had to do a conversion factor to make the density, the volume units match. Okay, because you can't cancel out 2 units that aren't the same unless, in this case, they are the same. All right, milliliter will cancel milliliter. That leaves us with gram. Does that make sense for mass? Yeah. 7.13 times 36. Calculator gives me 256.68. With sig figs, I have 3 sig figs here, 2 sig figs here. I need 2 sig figs. We're going to call this 260, and my unit is grams. That's my answer. A 140-gram piece of tin, density 5.75 grams per milliliter, is dropped into a graduated cylinder. The new water level is 68.2 milliliters. I should have clarified, there was water in the grad cylinder. The new water level is 68.2 milliliters. What was the original water level? So this gets at the concept of water displacement as a means of measuring volume. If you have an irregularly shaped object that's small enough to fit in a grad cylinder, you fill the grad cylinder part way, measure the water level, drop the object in, and it will rise, and the difference in volume is the volume of the object. So what are we solving for? We're solving for the original water level. But to find the original water level, we just need the volume of the object, and then we'll compare it to the new water level. So we're solving for V. dmv. V equals m over d, which equals 140 grams divided by my density, which is 5.75 grams per milliliter. Let's check our units. Gram cancels gram. Milliliters is left in what I call the double denominator. It's the denominator within the denominator. I'm sure your math teacher has a better term than that than I do. But I call it the double denominator. It's like the reciprocal of the reciprocal. It comes up to the top. That's our new unit. This makes sense. Does milliliters make sense for volume? Of course it does. So 140 divided by 5.75. Let's check our sig figs. 140 point, that's 3 sig figs. 5.75 is 3 sig figs. The answer is 24.3 milliliters. Now that's not our final answer. That's the volume of the object. So if the new water level is 68.2 and the object is 24.3, that means that it must have been 24.3 lower than it is now. So we simply subtract to get the difference. 68.2 minus 24.3 gives us 43.9 milliliters. Remember, when we add or subtract, we don't care about sig figs, we care about decimal places. 1 decimal place, 1 decimal place, 1 decimal place. That's our correct answer. That's the original water level, 43.9 milliliters. And this leads us to our last concept, which we're going to spend some good time talking about conversion factors. One of the best skills you can get in a science class. This is going to take you through the rest of your science classes, and it's a good thing to know just for the rest of your life in general. Great thing to learn. You may have learned this already, or you may learn in the future as dimensional analysis. I tend to call it conversion factors. It means the same thing. The idea behind conversion factors, it's like unit conversions. Like if I say I'm 6 feet tall, what is that in meters? That's conversion factors. Or if I say I live, 22 miles away, what is that in feet? What is that in meters? And we can do more than lengths. If an object has a mass of 5.7 kilograms, what is that in milligrams? What is that in pounds? It's about unit conversions. It's all based on the concept that multiplying something by 1 doesn't change its value, but it can change its unit. For example, 1 foot equals 12 inches, right? We all agree? Well, I can now turn this into a fraction where I have 1 foot divided by 12 inches. Since 1 foot equals 12 inches, I'm dividing something by itself. This equals 1. I can also flip this and say 12 inches over 1 foot. That also equals 1 because they're the same thing. So if I multiply something by this, I can change its unit but not change its value. And that's what we're going to do. If I multiply something by this, same thing. I can change its unit but not change its value. That's the key. We're going to multiply things by fractions that equal themselves. Okay. Now, before we do this, let's lay some groundwork, things you have to know. If you watch my video part 1, you'll recognize the 4 things on the left as my rapid fire conversions. These are the metric conversions that I would say you're expected to know fairly quickly right off the top of your head. Now, these are all based in meters. This works for liters. This works for grams. Okay, so understand that milli is 1/1000th. So there's 1,000 millimeters in a meter. Centi is 1/100th. So there's 100 centimeters in a meter. Kilo is 1,000. So there's 1,000 meters in a kilometer. And centi compared to milli, it's a 10-to-1 difference, 10 millimeters per centimeter. The top of the right one, you should know this from the volume lab. 1 milliliter equals 1 centimeter cubed. And the last 2 are USCS conversions, American style conversions. This one right here is what I call the bridge that gets us from USCS lengths to metric lengths. 1 inch equals 2.54 centimeters. That's a good one to just always memorize. Good to know. Even if you call it 2.5, just if you memorize it like 2.5, but you should use 2.54 for these conversions. And finally, 1 mile is 5,280 feet. We'll be practicing with some mile to feet conversions at some point during our conversion factors. Okay, so these are conversion factors that you should know. There are plenty of other conversions you'll need, but there should be in your notes. Okay, let's go with an example, and I'll show the process through this example. Convert 0.00521 kilometers to centimeters. Now, I know some of you are saying, hey, I remember learning this. Can't we just sweep the decimal point? Yes, you can. That works for this particular problem because you're working with one of those, King Henry died by drinking chocolate milk prefixes. But the concept of conversion factors goes well beyond those 6 prefixes. So I want to demonstrate not just sweeping the decimal point. Let's go through the actual process. So what we need to do is decide on a path to go from kilometers to centimeters. Well, if I asked you right now, how many centimeters are in a kilometer? You might be able to tell me, but probably not. But you should know kilometers to meters, 1,000 meters in a kilometer. And you should know meters to centimeters, 100 meters in a centimeter. Wrong. Whoops. Don't clip that and send it out. 100 centimeters in a meter. So these are our 2 pathways here. Okay. What we're going to do is use these to get us here. Now, let's write what I call our equivalences. You can even call them your conversion factors. What is the conversion factor between kilometers and meters? It's that 1 kilometer equals 1,000 meters. And to go from meters to centimeters, it's 1 meter equals 100 centimeters. Okay, these are the 2 conversion factors, or I call them equivalences, that will get us to where we need to go. Once we have our path planned and our equivalence written out, we grab the starting point, which is this. That's where we're starting. The end point is the centimeters, and we're going to rewrite it as 0.00521 kilometers. We're going to put this in parentheses, but in the top part of parentheses like that. You can even say over 1 if you want. I've seen people do that. We're then going to multiply this by something over something. That something over something must equal 1, but have different units in order to change our units here. We're looking to convert the kilometers. So we're going to use that top fraction. Now, we have a choice. We can multiply this by 1 kilometer over 1,000 meters, or we can multiply it by 1,000 meters over 1 kilometer. Now, you can't multiply it by 1,000 kilometers over 1 meter because 1,000 kilometers does not equal 1 meter. That wouldn't equal 1. We would get the answer wrong. The question is, which of these 2 in green would get our unit to cancel? The bottom one. Notice, if you put 1,000 meters here and 1 kilometer here, the unit, as long as you have 1 on the top, which this is, the one that's by itself is its own numerator, this will cancel and we'll be left with meters. If you put this one here, we would end up seeing kilometers squared over meters, which makes no sense. So that is not correct. All this did was it converted us into meters, and now we have one last step to do. Let's do one more conversion factor. We have 1 meter equals 100 centimeters. Our 2 options are 100 centimeters over 1 meter or 1 meter over 100 centimeters. Remember, to cancel a unit out, you need it to be on the top of one and on the bottom of the other. So we're going to put our 1 meter on the bottom and our 100 centimeters on top. We're going to cancel the meter and the meter. And 2 things we always want to check. First, will the units cancel? Yes, they will. And second, does each of these conversions equal itself? For this one here, does 1,000 meters equal 1 kilometer? Yeah, it does. Does 100 centimeters equal 1 meter? Yes. And you will likely make a mistake at some point, a mistake that you're thinking, I would never make this mistake, but it's a mistake like I made when I said that 100 meters equals 1 centimeter. Okay. I've seen people make mistakes with like feet and inches where they say 12 feet equals 1 inch. I've seen people say 5,280 miles equals 1 foot. It happens. It happens to me. It literally happened to me 5 minutes ago. So you want to make sure that you double check that your parentheses are equal to themselves, meaning that the numbers in the units are correct in that sense. Okay, notice We have canceled units. There's only one unit left, which is centimeters. That's what we're looking for. We do the math here. So we're going to multiply our numerators and divide our denominators. Now you don't need to divide the ones, it's unnecessary. And my suggestion for this, don't plug the entire long thing into your calculator all at once. For this one, it's probably fine. But eventually you'll get to the point where there's numerators, there's denominators. Don't do it all at once. Start here and do one step at a time and hit equals every time. So 0.00521 times 1,000 equals, times 100 equals. And there's my answer right there, 521. And the unit is centimeters. Now, sig figs. We learned in a couple videos ago, when you multiply or divide, we go with the smallest number of sig figs. The number 1,000 has one sig fig, but this is not going to limit our sig figs. The fact that there's 1,000 meters in a kilometer is true by definition. It's infinite sig figs. We're not going to limit our sig figs by anything that's true by definition, such as this, or such as the 100 centimeters per meter, true by definition. So for conversion factors, you really want to just look at the starting number, count your sig figs, and match it. How many sig figs in 0.00521? 3. How many sig figs in 521? 3. That's our answer. Now you might be looking at your computer and saying, I solved this one 7 minutes ago. I swept the decimal place 5 times. Why can't we just do that? Well, the answer is you can for this very rare type of question where you're going from one of the King Henry units to another of the King Henry units. But that's not going to help you with something like this, where we're going from millimeters to feet. So that's why the concept of conversion factors is important to know here. Let's work this one out. Okay, our starting point is 3.2 feet. We're looking to go to millimeters. Let's plan our path. Well, how many millimeters in a foot? I have no idea. Yes, you could look it up, but that defeats the whole purpose of the exercise and the strategy, okay? And again, you might be saying, it's 2021. Can't we just use our phones to figure out all this stuff? This concept of conversion factors goes well beyond unit conversions that you can easily look up on your phone. Trust me, it's a way of organizing complex problems that you'll be using throughout your science career and even beyond. I really, really encourage you to learn the basics of it now with stuff you can Google on your phone. I'm not trying to live in the 19th century here, but the process, once you learn it and practice it, it will help you in the long run, believe me. So we're going from 3.2 feet to millimeters. I have no idea how many millimeters in a foot, but what do I know? Well, I know that there's 12 inches is equal to 1 foot. And I know that 1 inch equals 2.54 centimeters. I memorized that one. Oh, and I know that 1 centimeter equals 10 millimeters. This is the path we need to get here. So I've written out the equivalences that I need. Our starting point is 3.2 feet. Let's get there. All right, we started in feet. We're going to go to inches using this. So do I say 12 inches over 1 foot or 1 foot over 12 inches? 12 inches over 1 foot. Let's check 2 things. Feet cancel feet. Good. Confirm that we wrote the numbers correctly. Are there 12 inches in 1 foot? Yes. Next, we're going to go from inches to centimeters using this one. So I can either say 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. I need my inches to cancel, so I need my 1 inch on the bottom and my 2.54 centimeters up top. Inch cancels inch, and we're good. 2.54 centimeters per inch, yes, that's correct. One more. 1 centimeter equals 10 millimeters. So I'm going to put my 10 millimeters up top, my 1 centimeter on the bottom. Cancel, cancel. Confirming that yes, 10 millimeters is 1 centimeter, good. At this point, the only unit left is millimeters, which is what we're looking for. And again, we have only numerators. Let's go one at a time here. 3.2 times 12 equals, times 2.54 equals, times 10 equals 975.36. Now we're going to look at our what's limiting us in terms of sig figs. So my sig figs are given as 2 sig figs from the 3.2. We're not going to limit ourselves to 1 sig fig because of the 10 millimeters. That's true by definition. Same with the 12 inches, although 2 sig figs wouldn't limit us anyway. So with 2 sig figs, 975.36 becomes 980 millimeters. Okay. There are 2 variations of these, two kind of tricky ways of showing these. What we just did are what I call linear or one-step conversions. It's not one step. It's like, well, it's not like these where we have cubic or square. In this one, it asks how many cubic centimeters are in 2.38 cubic meters. Now, to solve this, what I don't suggest you do is write the number of cubic centimeters in a cubic meter. I mean, if you can look that up, but it's deceptive. And the answer is not 100. Let me quickly show you why. How many centimeters are in a meter? 100. But there are not 100 cubic centimeters in a cubic meter. This is a meter stick. This is a second meter stick. This is a third meter stick. I don't know how well this is going to show up on camera, but I'm trying to hold these out in a 3-dimensional like shape where I have a meter long, a meter wide, a meter tall. Picture this being the side of a cube, 1 meter long on every side. How many 1 centimeter by 1 centimeter by 1 centimeter things? Think of Monopoly houses, if you know Monopoly, or miniature game dice. How many of those could you fit in this cube? 100? No, it's actually 100 times 100 times 100. What's that? Let's see, 100 times 100 is 10,000. Is it a million? Something like that. Something like a million of them will fit in there. Here's how I suggest you solve the cubic or square conversion factor problems. Start in the linear. Start with length to length, meaning 1 meter equals 100 centimeters. Don't cube this. Wait, definitely do not do this, because that is absolutely wrong. This is not true. Here's what you want to do. Write it in the linear form. Then we're going to start our problem. Starting point, 2.38 cubic meters times 100 centimeters over 1 meter, close parentheses. Will this solve our problem? No, but notice what it will do. It'll get one of the meters out of there. So what can we do? Well, you have 2 options. You can cube the outside of this, not the inside, the outside. Or what I prefer to do, it takes an extra 20 seconds, but I like it better. Repeat this again. And repeat it one more time. Now look at the units. We have meters cubed as our numerator on the left side. We have meter, meter, meter as our denominator. That will cancel. Meters cubed divided by meter, divided by meter, divided by meter, cancels. What are we left with? Centimeter times centimeter times centimeter. That's centimeters cubed. So notice what we've done here. We've multiplied it by 100, by 100, by 100. 2.38 times 100 equals, times 100 equals, times 100 equals 2,380,000. 2,380,000 centimeters cubed. That is how many Monopoly houses you could fit in 2.38 of those meter things I just showed you. Okay. Here's one with squares. We should be able to do this one fairly quickly. Let's plan our route. So we have square meters to square feet. Because we're starting in square meters, it says how many square feet. Now, let's not think in squares, let's think in linear. How many feet in a meter? It's not 3. It's close to 3, but it's not 3. We can go from meters to feet, not in one step. Yes, I know you can look it up on your phone, but the process is the important thing here. And at the start of this slideshow, I told you the bridge to go from metric to USCS and vice versa is that 1 inch equals 2.54 centimeters. That's the bridge across from American to metric units. Now, how do we go from inches to feet? Easy. 1 foot is 12 inches. How do we go from centimeters to meters? Easy. 1 meter is 100 centimeters. This should get us where we need to go. Our starting point, 0.84 meters squared in parentheses. Quick note here. The parentheses need to go outside the square, or better to say, the square needs to go inside. It's already meters squared. Do not go like this, because that does change it, because now you're squaring the 0.84. That is wrong. If the problem tells you you have square meters, you already have square meters. So put the square inside. Just like this problem, I started by putting the cube inside the first parentheses on the left. If I put the cube outside, I would then multiply by 2.38 and then again by 2.38 and get the wrong answer. Okay, so 0.84 meters squared. Let's go from meters to centimeters first. So we're going to multiply this by 100 centimeters over 1 meter. When I do these quickly, I often even drop the 1 and I'll say 100 centimeters per meter. Because it's not like I'm going to say divided by 1 in my calculator anyway. Okay, that gets us halfway there. Let's do it again to get a second one. 100 centimeters per meter. That will cancel our meters and it leaves us with centimeters squared. Now that we have centimeters squared, let's go to inches squared. Let's see, I need my centimeters on the bottom. So I'm going to go my 1 inch over 2.54 centimeters. And I'm going to go 1 inch over 2.54 centimeters. Centimeter cancels centimeter, centimeter cancels centimeter. I'm left with inch times inch, and I'm double checking that, yes, I wrote these correctly. If you run out of room, just move on to the next line. I probably have time for one more conversion here, or room for one more. So we're in inches. Let's go to feet. I can probably squeeze this in. So multiply it by 1 foot over 12 inches. 1 foot over 12 inches. Okay, and that will get my inches to cancel inches, inches to cancel inches. I'm left with feet times feet, which is feet squared, which is what I'm looking for. Everything is canceled except for the thing I want, which is square feet. Now notice I have numerator units and I have denominator units. I really encourage you, do not try to plug all 6 or 7 of these in all at once. You're likely to make a mistake and your calculator might mess up in terms of PEMDAS. I definitely suggest you go one at a time like this. Start on the left, 0.84 times 100 equals, times 100 equals. Now here, we're going to go divided by 2.54 equals, divided by 2.54 equals, then divided by 12 equals, divided by 12 equals, and the answer I get, 9.04168, and so on. Let's check our sig figs. 2 sig figs in my starting number. Everything else is true by definition. So we're going to go with 9.0 feet squared. This kind of makes sense too, because a meter is about a yard, which is 3 feet. So you can think of it like 3 feet on either side. 3 by 3, 9. 9.0. Okay. The last type of tricky problem is what I call a numerator and denominator problem. This is when you have a something per something unit converting into a different something per something unit, such as miles per hour into meters per second. Or we see this a lot with density, grams per milliliter into kilograms per liter, something like that. Okay, so here, the way we set it up is miles per hour. Treat this as numerator, denominator, and I highly suggest you write this as 65.0 miles per 1 hour, or just per hour without the 1. Don't write it as 65 miles per hour like this. I don't think you should write it like that, and definitely don't write it as 65 like miles per hour. No. The way to set this up is to have your numerator on top, your denominator on the bottom, And when it's per, that's your denominator. So 65 miles over 1 hour is our starting point. And the way this works, we're just going to treat it like two problems in one. We're going to convert our numerator from miles to meters. We're going to convert our denominator from hours to seconds. So it's going to be a lot of steps, but it should be pretty straightforward. We're not going to square anything. We're not going to cube anything. Let's plan our route out. Miles to meters. How many meters in a mile? I have no idea. So we're going to step this together, piece together stepwise. We can start in miles and go to feet. You should know that one. 1 mile is 5280 feet. I know that if I have feet, I can go to inches. 1 foot is 12 inches. I remember from last time, the bridge to go from American to metric is that 1 inch is 2.54 centimeters. And I know that there's 100 centimeters in a meter. These 4 steps will get our miles into meters. We also need to get our hours into seconds. How many seconds in an hour? You might know that, you might not. Let's not do it in one step. No reason to jump steps here. It's about the process. If you don't know how many seconds are in an hour, I'll bet you know how many seconds are in a minute. 1 minute equals 60 seconds. And I'll bet you know how many minutes are in an hour. 1 hour equals 60 minutes. And that's all we need to go from seconds to hours. So let's pick which we want to convert first, the miles or the hours. Let's do the miles first. You can go either way. Okay, so to get the miles into meters, the first step is to get it from miles into feet. Look at the setup. Here's what we need. Times 5280 feet per mile, or per 1 mile. Mile cancels mile, double checking this. Yes, that's correct. Feet to inches, 12 inches per foot. Feet cancel, yes, that's correct. Inches to centimeters. All right, 1 centimeter, 2.54 inches. Yes, we cancel, but, mistake. And this is why we double check. It's not 1 inch is 2.54 centimeters. In fact, or sorry, it's not one centimeter was 2.54 inches. It's 2.54 centimeters over 1 inch. So double check that you don't accidentally mess up those units or the numbers like that. Okay, that gets us centimeters. Let's go to meters. So 1 meter over 100 centimeters. And notice we now have meters per hour. We're close. We're looking for meters per second. Let's just keep working right through it. Keep with the setup here. How do we go from hours to seconds? Well, it's going to be a 2-step process. First step, hours to minutes. Now, every time we've set up a conversion factor to this point, you've put the unit you want on top and the unit you want to cancel on the bottom. Now that changes because the unit we want to change is already our denominator. So we're going to need our 1 hour at the top and our 60 minutes on the bottom. 1 hour on the top, 60 minutes on the bottom. And notice now the hour cancels the hour, and we're now in meters per minute. One last conversion should be all we need. I'll just do this down here because I ran out of room. I have 60 minutes on the bottom. I'm going to multiply that by 1 minute on top and 60 seconds on the bottom. And how did I decide which to put on top? You need it to cancel by having 1 on the bottom, which I see 60 minutes on the bottom, and 1 on the top. So I put my 1 minute on the top. Minute cancels minute. I'm left with 60 seconds on the bottom. And if you look at all the units that are canceled and all the units that are left, I'm only left with meters per second, which is exactly what we're looking for. Let's solve. 65.0 times 5280 equals times 12 equals times 2.54 equals divided by 100 equals divided by 60 equals divided by 60 equals 29.0576. My original measurement here was 3 sig figs. Even though I'm doing things like multiplying by 12 and dividing by 60 and 100, those are all true by definition. Not going to limit our sig figs. We're going to go with 3 sig figs, 29.1 meters per second. Why do I feel like I did something wrong here? I think that's faster than it should be. Let me check. 65 times 5280 times 12 times 2.54 divided by 100 divided by 60 divided by 60. I'm second guessing myself. Hold on. I don't have my phone with me. I'll catch you later if there's a mistake. 29.1 meters per second. Okay. One last problem. The density of a piece of metal is listed as 13,900 kilograms per meters cubed. What is this in grams per milliliter? So notice we have a per problem, meaning a numerator and a denominator. We also have a cubic meter in here, which might cause another issue as well. Let's plan our path. So we have kilograms per meter cubed that needs to eventually become grams per milliliter. Kilograms to grams, easy, right? Yeah, that's a one-step process. 1,000 grams equals 1 kilogram. Meters cubed is a volume unit. We're going into a different volume unit, milliliters. How many milliliters in a cubic meter? I don't know. But I could tell you how to get from meters cubed to centimeters cubed. We did this already. 1 meter equals 100 centimeters. Not cubic meter or cubic centimeter, linear. 1 meter is 100 centimeters. That's going to get us there. We're just going to have to cube it. Now that's going to get us into centimeters cubed. Can you tell me how to go from centimeters cubed to milliliters? I hope you can. It's 1 to 1. We talked about it. 1 milliliter equals 1 centimeter cubed. This should be all we need. So 13,900 kilograms per meter cubed. Let's go kilograms first. Multiply this by 1,000 grams per kilogram. Cancel that, and yes, that makes sense. Now, to go from meters cubed to centimeters cubed, I'm going to multiply this by 1 meter over 100 centimeters, 1 meter over 100 centimeters, 1 meter over 100 centimeters. Or you could multiply by 1 meter over 100 centimeters, close parentheses, cubed. If you're good with math calculator, that's fine. This means that my cubic meter cancels my meter, meter, meter. I'm left with centimeter, 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 which is centimeters cubed. My last conversion is mathematically unnecessary, but important to include because of the unit. I have centimeters cubed on the bottom. I need milliliters on the bottom. How do we do this? 1 centimeter cubed per 1 milliliter. Centimeter, 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 cancel centimeter cubed. Now look at all the units that are left. It's only grams per milliliter, which is what we're looking for. Here we go. 13,900 times 1,000 equals divided by 100 equals divided by 100 equals divided by 100 equals. The last one, I don't need to do anything in my calculator. It's 1 over 1. The answer is 13.9 grams per milliliter. There we go. Okay. Good luck with the rest of these, and of course, go to Extra Help in the morning. The schedule should be posted with the Extra Help sessions, and I wish you the best of luck in whichever level chemistry you are.